Alright guys, this video is connected to what we did yesterday, the notes that we took yesterday. What you're learning with this video is about the orbital notation, exactly the exact address or the quantum address for your elements and how to place the electrons. Notice these things right here. The S levels has 2 electrons, P has 6, D has 10, and F has 14. Just bear with me and it'll all make sense. Each of these boxes that you see here can hold 2 electrons. Each of these can hold 2 electrons, and they have to be placed like this. One arrow up, one arrow down to show the opposite spin, because each electron sort of has a unique quantum address. All right, each of these elements have unique addresses as well. So the Aufbau principle states that an electron will occupy the lowest energy orbital first, which means like 1s has to get the electrons first, or the 2s has to, as you're filling them in, you cannot just jump these orbitals. First 1s, then 2s, then 2p, then 3s, then 3p. Hund's rules state that all same energy orbitals must be filled by 1 electron each before any electron can pair up, okay? So which means what? Like kids on a bus, okay? 2s, which means that when you're placing electrons, it's like each of these are going to get individual arrows first for representing 1 electron before you start pairing them up. It's like kids on a bus. They get on a bus, they don't want to sit with anyone, they see empty seats and they want to individually fill those seats before they pair it up. That's Hund's rule. Let's look at the next slide. Make sure you have your periodic table. Get your periodic table out, please. Aluminum has 13 electrons. We're going to place 13 arrows here, okay? We're going to start out with 1s. All right, remember, I have to place 13 arrows. Now, remember, Hund's rule says that P's, or the energy levels, let's look at Hund's rule definition. Whoops. All same energy orbitals must be filled by 1 electron each. So same energy orbitals are P's, which has 3 boxes, D's, which has 5 boxes, F's, which has 7 boxes. So the P's have to be filled, each of them. So 1 arrow here before I start pairing them up. That's 13 electrons. S is sulfur, it has 16 electrons. Start placing these arrows, okay? So go ahead and pause this video and see if you can do this yourself. Now notice how I place the sulfur arrows. First, each of those P's get them, then you start pairing them up. You're not going to do this right here. No, don't do that. That is wrong. Find RH in the periodic table. It has 45 electrons. Let's go ahead and place those arrows. Start counting them until you reach 45. All right, and then DY. DY has 66. Let's place those arrows. Pause the video and see if you can do it yourself, okay? Now, after this, let's go ahead and show you an easier way. Get your periodic table and some highlighters to mark your periodic table. Here we go. These right here, group 1 and group 2, are S. This right here is D. These right here are P orbitals. And the one at the bottom are F. So please go ahead and label this, all right? Because that's gonna make it very easy for you to do this work. Let me see if I can change this to blue. All right, this right here is 3D. This whole row from scandium to zinc is all 3D, okay? This is all, once again, let me show you clearly here. This whole thing right here is 3D. This is D, start with 3. This is 4D, 5D, and 6D. S starts with 1s, 2s, 3s. This period is 3, so 3s, 4s, 5s, 6s, 7s. The P's are gonna be 2p. P starts with 2p, 3p, 4p, 5p, 6p, 7p. Why with 2? Because you don't need any more, because helium is 1s2, okay? So helium's address is 1s2. Lithium will be 1s2 and 2s1. 3 electrons. Each of this superscript represents electrons. 2 plus 1 is 3. Lithium has 3 electrons. Let me show you another one right here. Look at these. These tell you the exact address for your element, okay? So if I say 2p6, that's neon right here. 2p6 is neon. That's the exact location, okay, of neon. Now let's go to our PowerPoint. I hope you can pause the video and, you know, highlight the stuff. Let's show you an easier way to do this. Find ND in the periodic table. Let's go in our periodic table and find ND. Now, ND is right here, okay, which is 4F. Remember, I told you these are Fs, and your periodic table that I've given you also has this. This is S block right here. This is D block right here. This is P, and this is going to be F, okay? So ND is, this is 4F1, 4F2, 4F3, 4F4. You're gonna come in here, find your element, and start populating 4 arrows in your 4F levels. 1, 2, 3, 4. And then you don't even need to think about it. You can just start populating all of these arrows before, because we need to account for how many electrons. 60 electrons, so you put 60 arrows. Let's do the next one. Strontium. Strontium has 38 right here, 38 electrons. So we're gonna find strontium. That's 5s2. You're gonna come in here, put your 2 arrows for 5s2, and just start filling rest of them out. Okay. Next one is Sp, which is antimony. Antimony is right here, 51 electrons. Antimony is in P zone. Look, 5p3. I'm gonna put 3 arrows in 5p. 1, 2, 3, and then start filling them up. All right, I hope this video was helpful. Please watch this video before you start doing the worksheet. I have another video for the worksheet as well. All right, thank you. If you still have any questions, let me know.